Good day, dear students. Today we will be entering topic 2 integration, subtopic 2.4 definite integrals. Let's look at our learning objective for today. At the end of the lesson, everybody must be able to use the properties of a definite integral and also evaluate definite integrals. So these are the properties that we have, for definite integrals. Okay. Let's look at the first properties. When you integrate a until b upon c dx, the answer is equals to c b minus a. So basically how we get this, when we integrate c, we actually get cx from a until b. So we are going to substitute the definite integral b minus a into the x. That's how we get c multiply b minus a. And when we have addition or subtraction of a two function for definite integral, we can separate the two functions and integrate them separately, a until b. For the function with constant a until b, we can always bring out the constant and integrate a until b. Now, if you integrate a until a, you will be getting 0. That's because, let's say your integration is x, and we will be getting x squared over 2. Let's say the indefinite integral is 1 until 1. So a until a, let's say 1 until 1. We will be having 1 over 2 minus 2, and that is equals to 0. Okay, and the next properties, if we integrate a until c, it is the same as integrating a until b plus b until c, where a is less than b less than c. So on the number line, let's say we have a, b, and c. So if you integrate a until c, is the same as you integrate a until b plus b until c. Okay, and if we have fx greater than 0, and the definite integral is a until b, then if you integrate until a until b, you will definitely get a value greater than 0. This is because a is less than b. So we will be taking b minus a. That's why your answer will definitely be greater or equals to 0. Now let's try to answer example 12 by using the properties of definite integrals. So given integrate fx 1 until 3 is 6, integrate fx dx 3 until 7 is 9, and integrate 1 until 3 gx dx is negative 4. So the first question they are asking us to find, what is the integration of 1 until 3, 3fx dx. So we are going to use the properties that we learned earlier. So 3fx dx, we can always bring out the 3. Okay, so we can always bring out the 3, integrate 1 until 3 fx dx. And we know when you integrate 1 until 3 fx dx, you actually get 6. This is given in the question. So 3 multiplied 6 is 18. So to answer this question, we don't even have to know what is fx. We just have to know the properties of definite integral. Now what happens when you integrate 3 until 1 fx dx? So we know 1 until 3 is 6. So 3 until 1 is the same as negative of 1 until 3. Okay, the other way around. So negative of 1 until 3. 1 until 3, integrate 1 until 3 fx dx is 6. So the answer is negative 6. Okay, next we are going to see what happens when you integrate 1 until 3, 2fx minus 4gx. So we are going to use the properties 1 until 3, 2fx minus 1 until 3, 4gx. So we can separate these two functions. Okay, so do not forget to write your dx for both. Okay, so we're going to start with the first part here. Integrate 1 until 3. 2fx dx, we can bring out the 2. So basically the first part here we will have 2 integral of 1 until 3 fx dx, and same on the second part here we can bring out the 4 integral of 1 until 3 gx dx. So we have the answer for 1 integrate 1 until 3 fx dx, which is, so if we see here 1 until 3, the answer is 6 minus with 4 1 until 3gx. 1 until 3gx is negative 4. So we are just going to substitute negative 4 here. So 12 minus 4 times negative 4 is the same as 12 plus 16. So 12 plus 16, we will be getting 28. The answer for C. Example 12C. Okay, so I hope you are able to follow this. Next, we're going to look what happens when we integrate 1 until 7 fx dx. Of course, in the given information, we do not have 1 until 7, but we have 1 until 3 and 3 until 7. So we know 1 until 7. We do not know the integral 1 until 7, but we know the integral 1 until 3 is 6 and 3 until 7 is 9. So what we are going to do to find 1 until 7, what we are going to do, we are going to separate this as 1 until 3 plus with 3 until 7 fx dx. Okay. So if you look at the given question, 1 until 3, the answer is 6, and 3 until 7, the answer is 9. So 6 plus 9, we will be getting 15. So that's how you use properties of definite integral to solve the question, and you don't really have to know what is your fx or your gx to answer these questions. Now let's look at example 13. Okay, now we know our fx, but we want to find the definite integral of 5x dx. So when we integrate 5x, we get 5x squared over 2. And for definite integral, we don't have to write the plus c. All we have to do is substitute 5 square minus with substitute 1 square over 2. So using the calculator, we will be getting 1 to 5 over 2 minus 5 over 2, and the final answer is 60. For the next question, integrate pi over 6 until 2 pi over 3 upon sine x dx. We have to be very careful when we integrate function involving trigonometry and is a definite integral. So make sure your calculator is in the mode is in radian. This is very important. Then only we see how to integrate sine x. So integration of sine x will give us, when we integrate sine x, we get negative cos x from pi over 6 until 2 pi over 3. So negative cos 2 pi over 3 minus with negative cos pi over 6. Okay, so you have to use your calculator to get the final answer, which is 1.366. Make sure the calculator is in radian. Okay, so we will be using definite integral to find the area and volume, which is our next learning outcome. Find the area of a region bounded and also a volume. So all this, we can only solve this question if we know how to solve definite integral. Okay, that's all for this video. Thank you, students.